Welcome to the 6th installment of the video of the week. We're going to start this chapter by discussing complex numbers. This involves the idea that you can now take the square root of a negative number, using the idea that the square root of -1 is now called I. To be honest, I usually don't get too many questions about this. Feel free to send them along if you have them. The biggest issue that my students had last semester, especially on the final exam, was completing the square with quadratic functions. I'll do a simple example of completing the square in this video, and then I'll do a slightly more complicated example. Now, completing the square is a way of rewriting a quadratic function in a different form. If we complete the square on a function that looks like this just basic ax squared plus bx plus c, a lot of people would call this standard form. If we complete the square on this function, we end up with an equivalent function, but it's just written in a different form. But the function written in this form gives us the vertex of the quadratic right away, which can often be important. You'll notice that this a here is the same as the a here, and h and k are actually found by doing the process of completing the square. And once you find the values for h and k, you know right off the bat that the vertex of this quadratic is the point hk. Okay, let's actually do an example here. Let's take a look at x squared plus 6x plus 25. All I've done is taken a basic quadratic and plugged in a equals 1, b equals 6, and c equals 25. If we're going to complete the square on this function, the first step is to look at b divided by 2 squared. In this case, that's 6 divided by 2 squared, which is 3 squared, which is just the number 9. Now I'm just going to copy this function down. I'm going to leave a little bit of space, because what we're going to do is we're going to take that number that we got right here, in this case 9, and I'm going to add it to the function. And to make that a legal operation, we're also going to subtract it from the function. Now I'm just going to copy that line down again, and I'm going to point out what happens every single time here, if you've done this right, is that the first 3 terms become what we call a perfect square. We can write x squared plus 6x plus 9 as the binomial x plus 3 quantity squared. You can double check that if you like. You can FOIL this out or distribute this thing out to get back these 3 terms. Now the 25 minus 9, I'm just going to do a basic subtraction. And now we have our quadratic function written in our vertex form, as I call it, because it's very easy to pick out what the vertex is from this formula. As you learned in the previous chapter, this is just a basic quadratic which is shifted left 3, and this plus 16 says we shift it up 16 units. What this tells us is that the vertex of our quadratic is just the point -3, 16. Let's take another look at an easy example, and then we'll do one more slightly more difficult. I would like to complete this square on g of x here. Like before, we're going to take a look at b over 2 and we're going to square it. I'm getting the number 4 here. I'm going to copy down the function, and I left a little bit of space so that I could add 4 and subtract 4. As always, these first 3 terms, if we've done it correctly, will form a perfect square. Those first 3 terms can be factored into x minus 2, the quantity squared. And then outside, we're left with a minus 13. We can see right off the bat that this is a basic quadratic function that's shifted to the right 2 and down 13. So our vertex is going to be the point to -13. Now, as you'll see in the homework, you're often asked to solve quadratic equations by completing the square. So we've taken the right side of our quadratic function, we've set it equal to 0. So what you would do is actually the exact same process. You would just rewrite this x squared minus 4x minus 9 as this x minus 2, the quantity squared, minus 13. Now what you have is an equation that's fairly simple to solve. We can add 13 to both sides. We can take the square root of both sides, don't forget the plus or minus. And then finally, to get x by itself, we can simply add 2 to both sides. And we have our answers for the solution of the equation x squared minus 4x minus 9 equals 0. Now, a couple of notes here. The first note is that if we're given this equation here, of course we could have just used the quadratic formula to solve, and we would have gotten the same answer. So if you're asking why would we ever want to complete the square, the answer is really in higher level math, we often need to rewrite something that looks like this in this form as something that looks like this in this form. The second point that I want to make is that by taking a function, setting it equal to 0, and solving for x, we have found the zeros of that function. In other words, we found the x-intercepts of that function. So this question could have been asked in that form as well. Okay, I want to finish this video up by doing a much more complicated version of completing the square. Completing the square becomes more complicated when a is something other than 1, because it tends to create fractions that we have to deal with. What we have to do is actually factor out that a. When we factor a 3 out of this quadratic function, we get this right here. And we're actually going to treat what's in parentheses here exactly the same as the way we treated our functions above when we were completing the square. The only difference is we have fractions now. So I'm going to say b is our 4/3. And now if we want to do b over 2 and square it, 4/3 divided by 2 you can think of as 4/3 divided by 2 over 1. Any way you think about this, you're going to end up getting 4/6, which then reduces to 2/3. And when you square a fraction, you square the numerator and the denominator separately. Okay, that would be a good point to hit pause on your browser and try to figure out what I just did there. I'll trust that you'll do that if necessary, and I'll continue the process. I'm just going to copy this function down, and I'm going to leave some room. I'm now going to add that 4/9, and I'm going to subtract that 4/9. Make sure that you keep both of those inside the parentheses, because they should both still be multiplied by 3 on the outside. Now, as always, the first 3 terms here should be a perfect square. It's not always obvious what that perfect square should look like, but if you've done everything correctly, the number that goes right here, you'll notice from previous examples as well, always appears up here. It's your b over 2 number. And of course, it's always a good idea to check your answer to make sure that this binomial squares to get the 3 terms above. Now we have to deal with fractions here as well because we want to subtract these. Finding a common denominator is how you add and subtract fractions. And doing this process fairly quickly, again you can hit pause on your browser if necessary, gives me 2/9 right here. Now we are almost finished. The last thing we want to do is distribute this 3 to this binomial that's squared right here, and also distribute that 3 to the 2/9. And then the last order of business is just multiplying this 3 by this 2/9. A lot of students will consider this 3 to be a 3 over 1. Multiply straight across the numerator, straight across the denominator, and reduce and you get the number 2/3. Copy our function down again, and we have successfully completed the square. Okay, so this is a quadratic that is shifted to the left 2/3 units. It's stretched vertically by a factor of 3, and it's also shifted up by 2/3 units. Okay, I hope that helps you complete the square. I'll see you in the next video.